Hello everyone. Today I'm going to solve this problem. I chose this problem from the 14th edition of Statics by R.C. Hibbeler. And as you see, I chose a 3D problem, and the number of the question is 3 67. Okay, the question says determine the maximum weight of the crate so that the tension developed in any cable does not exceed 450 pounds. Okay, so the equation that I need to write here is the uh, resultant or R vector that we defined as uh, sigma F or any force at the point A, because I want just to calculate any point respect to at the point A. I choose point A as my uh, point that I need to consider its equilibrium, and all forces that apply to point A must be equal a zero or a zero vector. And because it is a 3D problem, you can convert this to the three equation, sigma fx, or is better that I called rx equals sigma fx must be 0, ry, that is sigma fy equals 0, and rz, that is sigma fz equal 0. Okay, so as you see, we have three equations, and it makes sense. Why? Because uh, we have three a cable or three unknowns that I need to determine. Okay, to understand this better, let's show you the forces that apply to the point A. One force is here, so I call this TA. The other force, or because it's toward the B, it's better that I call TB. The other force is this force that we called TC, and the other force that I show here we called TD, TA, TB, TC, and TD. Uh, and also we have another force that I use a different color to show that, and this force is uh, the weight of this crate. So I can just simply write this as W. Okay, it is the force that all the forces that apply to this. And the question says the tension developed in any cable must be less than 440 pound. So it also means this inequality. TA and must be less than or equal 450. Also, it is for TB less than 450, and the first one should be uh, TB, and then TC, and then TD must be less than 450 pounds. Okay, I have to consider this. Okay, if I write the equation, the best method to write this equation first is uh, work with the coordinates of the given points. Okay, if I just write the coordinates of the given point, the point A, the coordinates of point A is is at the origin of the system of coordinates. So it is simply 0, 0, 0. The other point is point B. And the point B, the coordinate of point B, the x coordinate of point B is 1 because it is, sorry, the x coordinates of B is negative 2. Why negative 2? Because it is on the other direction of the x-axis, or negative direction of the x-axis. So the x coordinates of point B is negative 2. The y coordinates of point B is positive 1. The z coordinates of point B is positive 2. The next is point C. The point C coordinates are, the x coordinates of point C is negative, and because it is in the same distance, I mean just like this, I can show negative 2. The y coordinate of C is in the negative part of the y axis. So the y coordinate of C is, hold on, it should be, yeah, it is the y coordinates that is the same as negative 2, and the z coordinates is positive 1. So also I have to write for D. The point D is located on the x-axis, so it has just x coordinates, and x coordinate is 3, and the other coordinate is 0. Why? Because this point D is located on the x-axis, so the other coordinates must be 0. After writing them, now I have to calculate the unit vector along each cable. So if I use the the unit vector with u hat, unit vector of the AB. So u hat means unit vector, and unit vector is a vector that has the length of 1. So the length of any unit vector equals 1, and the direction is the same direction of the, for example, for u hat AB is the direction of cable AB. And to calculate this, it is easy. Why? Because I just need to divide AB vector by the length of AB, or magnitude of AB, and it gives you the AB vector. So for example, let's calculate the AB and AB vector. For AB, you have to write xb minus xa multiplied by I hat. I hat is the unit vector in the x direction, plus yb minus ya in the unit vector in the y direction that we call j, and also the unit vector in the z direction that we call k hat. So, and then it is the vector of AB, and then divide by the root. So for root, I can use this formula. I mean, xb minus xa squared plus yb minus ya squared plus zb minus za squared. Okay, simply if I just plug in the values from a and b, for u hat ab, I can write this. I can write xb, that is minus 2 minus 0. Because the xa is 0, it is just negative 2 I hat. For yb, negative 2 j hat. And for zb, it is it is for b, negative 2 I hat plus 1 j hat and plus 2 k hat. Why? Because the a is 0, so 2 minus 0, 1 minus 0, negative 2 minus 0, and so on. And all over this squared, negative 2 squared plus 1 squared plus 2 squared, right? So if I just want to simplify, this denominator is 4 plus 4 is 8. 8 plus 1 is 9. So root 9 is 3. So I mean this part in denominators is square root of 9 that we can simplify to 3. 4 plus 4, 8 plus 1, 9. Okay, now what we get? We get negative 2 over 3 I hat plus 1 over 3 j hat plus 2 over 3 k hat. It is just the unit vector of the a b direction, or a b cable. I have to do with the other one. For example, for the other cable is AC. So u hat of AC, the same technique. I mean, you have to divide AC by length of AC. So if I just use the same technique but with the C minus A, again, because A has 0, 0, 0, it is negative 2 I hat minus 2 j hat plus 1 k hat divided by square root of negative 2 squared plus negative 2 squared plus 1 squared. So denominator again is the same as 9, right? So square root of 4 plus 4, 8 plus 1, 9. So simply you can write negative 2 over 3 I hat, negative 2 over 3 j hat plus 1 over 3 k hat. And next is the AD. So u hat of AD, I follow the same thing. So AD as a vector divided by length of AD. And then again, because A has 0, 0, 0, I just write 3 I hat. And then we get 0 j hat and 0 k hat. That actually becomes the 0 values for the second and third coordinates, divided by square root of 3 squared plus 0 squared plus 0 squared. So simply we get, because it is just 3 square root of 9, so, and 3 over 3 is 1. So simply I can write I hat. I mean, the UAD is just I hat. And it was actually clear because this one is just in the x direction. So you simply can see that it is the same as I hat. Okay. After finding this, now I have to back to these 3 equations. If I write the 3 equations, because I need to write every vector, okay, let's show you. If I just use this to find the TB, so TB as a vector should be the value of TB times the unit vector of AB direction, U hat AB. Also here, I can write TC as a vector equals TC as a just a scalar or just a value, U hat of AC. Also, it's better that I call this U hat of AB. And last one, if I just write this as TD, TD simply is the value of TD times U hat of AD. That just we calculated here. Okay, now if I back and write the equation for each component, so I start from here. The Rx, that is sigma Fx, so all forces that applies to point A. So I just use the x coordinates of each, TAX plus TBX plus it's better that I start with TBX. We don't have TA. TBX plus TCX, the x coordinates or components of TC plus TDX, and also I have to consider the vector W. Okay, to show the vector W, let's show you here. The vector W is the magnitude, this magnitude in the negative z direction. So simply I can write this as negative WK hat. Why? Because as you see, W is downward, is in the negative direction of z, and if we assume this magnitude is W, so I simply write this one. So generally I have to write W x, that means the x component of this, and all of this must be 0. Also for the Ry, that is sigma Fy, the same thing, TBY plus TCY plus TDY plus WY must be 0, and also RZ, that is sigma FZ equals TBZ plus TCZ plus TDZ plus WZ equals 0. And if I simplify and plug in the values for each, TBX, okay, if I use this for TBX, I just need to work with the x component. So TBX is negative 2/3 of TB, because the x component of U hat is negative 2/3, so it is negative 2/3 of TB. TCX is the x components of TC, because the x components of unit vector is negative 2/3, so I write negative 2/3 TC. Also for TD, the x component is just I hat, I mean 1 I hat, so simply I just write plus TD. And for WX, there is no x component, so plus 0 equals 0. And I just write for this TBY, it is the y components of U hat, that is 1/3 of TB. The y component of TC, it is this guy, that is negative 2/3 of TC, For TD, uh, if you look at TD and the U hat of AD, there is no component, so you don't need to write, actually you just get 0 because the TD has no y component because it is in only there is the x direction. And for W the same because W has no component in the y. And finally for z direction, the z coordinates of u hat AB is 2 over 3 TB. The z components of TC is 1/3. And the z component of AD or TD is 0 because it only is in the x direction. And z components of the W, if you look at this, the z components of W is just negative W. So I just write negative W and everything must be equal 0. So we have this system of equations, and in this system of equations, we consider W as noun and TB, TC, TD as unknown. And our next step is to solve this system of 3 equations and 3 unknowns. Okay, now let's continue with simplifying this system of equations and try to solve this. If I just multiply both sides by 3 and rearrange them, I mean multiply everything by 3, both sides of each equation, and then try to rearrange, I get this system of equations. Negative 2TB minus 2TC plus 3TD, because multiplied by 3 everything is 0. TB minus 2TC equal 0 because we don't have any other thing, so which is just 0. And the last one is 2TB plus TC. If I move this to other side and multiply it by 3, we get 3W. Okay, now I have to solve this system of equations to find each of these TB, TC, and TD. If I move to the next page, I can continue here. So to solve this, if I just try to eliminate I mean, for example, between these two, because both are TB and TC, if I try to eliminate these two, if I multiply, if I call equation 1, equation 2, equation 3, if I multiply the equation 2 by equation 3 by 2 and add with equation 2, so equation 3 2 plus 2 times of equation 3, so equation okay, hold on, if I just use a different, yeah, I think different notation is better. Equation 1 2 3. Okay, now if I multiply this by 2 and then add by this, so I mean equation 2 plus 2 times of equation 3. So what we get? Equation, this equation by 2 times of this. So it is TB plus 2 of 2TB, that is 5TB. And then if I multiplied negative 2tc by 2tc cancels out, and then multiplied, just add by 2 times of this. So 0 plus 2 3 times 3, that is 6w. So from this I can find TB. TB equals 6 over 5w. After finding TB from this, from this equation, from equation 3, I can isolate this equation for TC. If I isolate this equation, it is 3w minus 2tb. And if I use this 3w minus 2 times 6 over 5w, and let's simplify more, I get 3w minus 2 times 6, 12 over 5w. So if I write this as 15 over 5, 15 over 5, 15 minus 12 is 3 over 5w. And then just back here, I can isolate this for TD. TD equals, I move these to other side and then divide by 3. 1/3 of, or is better to say 2/3. 2/3 of, I move this to other side, TB plus TC. I move this to other side, factor out 2 and divide by 3. So we get TB, that is 6 over 5w, plus TC, that is 3 over 5w. So we get 2 over 3 times 6 plus 3, 9 over 5w. And then can simplify more. 9 by 3 is 3. 3 times 2 is 6. 6 over 5w. Now that I get all the unknowns based on w, I know each of these based on this, each of these must be less than 450 pounds. So it must be less than 450 pounds. Also, this must be less than 450 pounds. Also, this must be less than 450 pounds. So, if I simplify this, I get W must be less than 450 divided by 5 times 6. So, if I use my calculator, it helped me to simplify this more. So if I go with this one, I get 5 times 450 divided by 6. So it is 375 pounds. And this, if I just solve the inequality for W, exactly we get the same. Why? Because these are the same. 375 pounds. And if I just work on this to simplify for W, I get 5 times 450 divided by 3. And the value that I get is 750 pounds. Okay, so after calculating this, the final W that you have to check, if I call this, for example, WD, because it comes from the TD, WB, and if I call this WC, the final W, or the W max that you can be applied, is minimum of these three W. Minimum of WB, WC, and WD. That means the minimum of WB is 375, WC 750, and WD, that is the same 375, all in pounds. And what is this? It is the minimum is 375 pounds. So it is the maximum weight that this crate can have. So the tension developed in any cable does not exceed 450 pounds, and it is the final answer. Okay, thank you for watching and have a good one.